Hi everyone, Part 3, Combining Transformations. In this section, all of the transformations so far will be applied into one equation. Consider the general function y equals f of x. If all of the previous transformations will be applied, then the general equation would be, okay, so we have y equals af bracket b bracket x minus h bracket bracket plus k. Okay, so there's all the transformations. Okay, remember A is the vertical stretch, B is the horizontal stretch, H is the horizontal slide, and K is the vertical slide. Okay, as with different parameters represent different math operations, the order of operations or bed mass has to be taken into account. Okay, remember multiplication, so A and B must always be done before addition and subtraction, the H and the K. Because reflections are negatives attached to A and B, they are done at the same time as stretches. That being said, this often makes the equations harder, so an easier way is to continue to separate the reflections and the stretches. So we're going to treat them as separate things. So remember, if we have an A value, let's just pretend A is negative 2, so we're going to say that that is a vertical, so y equals negative 2, I don't know, f of x. Okay, we're going to continue to say that this is a vertical stretch by 2 and a reflection in the x-axis. Okay, so we treat them as two separate things. If we do that, then we can follow the acronym SRT, so stretches, reflections, translations. Okay, and that will give us the correct order of operations. Okay, there is one extra consideration though, haha, funny, isn't there always? Okay, if there is a horizontal stretch and a horizontal translation in the same question, okay, scroll that up. In the same question, the equation has to be written as it was above, has to be written like this. Okay, for the graph to be drawn properly, the B and the H have to be separated like that. Here, I'll show you. Okay, the stretch parameter B must be factored away from the translation parameter H in order for order of operations to be properly accounted for. Okay, so I want you guys to consider the transformation here. Okay, so x squared and then 2x plus 4. Okay, at first glance you look at this and you say, okay, well, we do stretches first, so okay, that's a horizontal stretch by a half. Okay, and then the 4, oh look, that's going to be 4 to the left. Okay, great. However, when you graph these on your graphing calculator, so look at this, okay, sure, there's a horizontal stretch by a half. The red graph is definitely horizontally stretched, but look at this. There is only a horizontal translation of 2 units left, not the 4 that we expected. The reason why is because of order of operations. We didn't account for that properly. Okay, so the B value has to be factored out in order for it all to work. So now I've shown you here, okay, so 2x plus 4 has to be written like this. So what we do, so we say 2x plus 4, okay, and then we factor that. So each one has a common factor of 2, so we go 2x plus 2. Okay, now that of course is all squared, so we have to square it again. Okay, once we factor that B out, okay, now the graph does what we expect it to. So horizontal stretch by a half. Okay, so stretch by 1/2, and then a translation 2 units left. Okay, now a phrase that I commonly use is see the B. Okay, so you have to see the B, you have to factor the B, factor that 2 away from the rest of it in order for this all to work. Okay, so let's practice a few of these. Okay, so again, key ideas. So write the function in in that form, a, f, b, x minus h plus k, okay, in order to identify. So stretches and reflections may be performed in any order before translations. So I said SRT. Okay, but you can do RST if you really want, because these two, the stretches and reflections, are both multiplying operations, so it doesn't matter what order those go in. Okay, not a big deal. SRT works just great. Okay, remember, if the A and the B are negatives, and those are the reflections. Okay, so let's have a quick look at some of these examples and be on our way. So, describe the combination of transformations that must be applied to f of x in order to obtain the transformed function, then sketch the graph showing each step. Okay, so here we have a 3 there, so that is a vertical stretch by 3. Okay, and then the 2x is a horizontal stretch Okay, so the 2 is a horizontal stretch by a half. Okay, great. So it doesn't matter what order we perform these in, so you know what, I picked the vertical to be first, so why don't we just carry on with that. So remember, the vertical stretch takes all the y-coordinates and multiplies them by 3. So the y-coordinate, so the 1 gets multiplied by 3, so that becomes 1, 3. So 1, 2, 3. Okay, the 2 gets multiplied by 3, so that's now 6. So 1, 2, 3, 4, 5, 6. And the 3 gets multiplied by 3, which is 9. So 9, 9. Okay, so there is the first one. Okay, now I'll write in red again so we don't get mixed up. Okay, so now we take the x-coordinates and times them by a half. So the x-coordinate here is 1, so now that's a half. The x-coordinate for this guy is 4, so 4 times a half is 2. Okay, and the x-coordinate here is 9. 9 times a half is 4.5, or just 9 halves. Okay, and the final graph then works out to this. Okay, so that's how we do it. That's how we take each individual part and translate it or transform it. Okay, so next, number 2. Okay, describe the combination of transformations that must be applied to this function to obtain the transformed function. Sketch the graph showing each step. Okay, so here we have a horizontal stretch by a third, and this is one of those C the B ones. Okay, it looks like it would be 6 left, but it isn't. Okay, we have to write this, we have to separate the 3, the B value, from the 6, the H value. So this really is f of 3, and we just factor. So the common factor there is 3, so it's just x plus 2. Remember, factoring is a fancy word for divide. Oh, okay, so now that it's written properly, now we can do it right. So this is a horizontal stretch by 3. By 1/3, and a horizontal translation of 2 units left. Translation of 2 units left. Okay, great. Okay, so working through that, we have to do the stretch first. Okay, so the horizontal stretch takes the x-coordinate. Okay, that makes it 1/3. Okay, so that's about there. Okay, 4 times a third is 4/3, or 1.333, or 1 1/3, something like that. Okay, and then 9 times 1/3 is 3. So that jumps all the way back to 1, 2, 3. So right to there. Okay, so that's our first, that's the horizontal stretch part. Okay, and then the 2 makes it go 2 to the left. Now I'll pick a different color. Hey, how about we use orange? Why not? Okay, so this point goes 2 left, so he translates to there. Okay, so the 1/3 goes to here. Okay, the 4/3 goes to about there, and the 3 goes to the 1. Okay, and there we have our new graph. Okay, step by step. See what I mean by the C, the B? Okay, we have to factor that 3 away from the 6 in order to get it proper. Otherwise, we think that it moves 6 to the left, which is completely wrong, and believe me, that answer is going to be there on your unit exam, on your diploma exam. Okay, they always do that. So because we know they always do that, we have to be ready for it. And so see the B. Factor that B value away. Awesome. Okay, next, number 3. Okay, state the combination of transformations that should be applied to the graph of x squared in order to obtain the graph of this thing. Oh, that's big. Okay, all right, well, if we have a look at this, okay, so we're going to do the stretches first. Okay, and again, we could do the reflections first. It doesn't matter, they're on the same level, but we might as well pick with something and stay with it. So stretches first. So okay, there's a half here, so that's a vertical stretch by 1/2. We leave it alone. Okay, then we have the 2. That is a horizontal stretch by 1/2. Okay, remember the horizontal ones we flip over. Okay, we take the reciprocal of. Okay, now we do reflections. So there's, oh, that's the negative there. Okay, so that's the negative on the y, so that's a vertical reflection. Okay, so vertical reflections, remember, are here to down there, so that's over the x-axis. So we have a vertical reflection in the x-axis. Okay, great. Okay, and then we do the translations. So that is going to be 1 up and 4 to the right. So horizontal translation, 4 right, and vertical translation, 1 up. Okay, and there you have it. So then B says write the equation or the corresponding equation for g of x. So remember, if f of x is just x squared, so what we did in A is we just used the general function. Now we have a specific one. So it's really not that big a deal. Okay, so g of x equals. Okay, so now it's just the f of x part is x squared. So, okay, the negative 1/2 just stays there. Now it's going to be x squared. So we put all that stuff that was attached to the x inside. So it's just 2 bracket x plus, whoops, x minus 4, my bad. X minus 4 squared. Okay, so that is accounting for the f of x equals x squared, and then plus 1. So, right, your graphing calculator can't graph an f of x. It just doesn't. Okay, there's some general function, but now that we have that f of x is x squared, now we can actually make the real equation, and you could graph this on your calculator if you wanted. Okay, now mapping rules. Usually for this, everyone, mapping rules go one at a time, and it's just easier. So if we go x, y, now, okay, let's do the half first. Okay, so that's going to be the x stays the same, and then we have the negative 1/2 y. See, the mapping rules are nice because that just takes into account the reflection. You know what? Maybe that's too much. If it is too much, well, then you can just write it there, but we'll come back to it. Okay, so the y coordinate gets vertically stretched by 1/2. Then we can do the x coordinate, so that's going to be a horizontal stretch by 1/2. Okay, now we can do the reflection, so that's going to be 1/2 x, 1/2, negative 1/2 y. See, so we could have put the negative here and saved ourselves a step, right? We could have put the negative there, but oh well, it's really not a big deal. Okay, and then of course from here we had to go 4 right, so that's an x coordinate thing. So that's going to be 1/2 x, and then 4 right is just plus 4. I might as well do the y at the same time, so 1/2 y, and then we go 1 up. Okay, so that is our final mapping rule. And if you can go right from xy right to this, then go ahead. That's fine. I just find that step by step is just a little bit easier. Okay, and then now we're going to use that mapping rule and say, okay, where does the point 2, 4 land? So if 2, 4 is on the original function, y equals x squared, so where does it go now? Okay, well, tell you what, we just look at the mapping rule. So we go 1/2 times 2, right? A horizontal stretch by a half, so that goes to 1. So 1/2 times 2 is 1, plus 4 is 5. Okay, so that point moves to 5, and then the y coordinate, so negative 1/2 times 4 is -2, and -2 plus 1 is -1. So the point 2, 4 goes to 5, -1. Awesome. Okay, and then last one, example 4. So the graph of the function g of x represents a transformation of the graph of y equals f of x. Determine the equation in that form. Okay, awesome. So how we do this is we're going to look at width and height first. Okay, so how that works, let's look at width. The original graph is 1, 2, 3, 4, 5, 6, 7, 8 units wide. The new graph is only 2 units wide. So that means there was a horizontal stretch by 1/4. Does that make sense? It goes from 8 to 2. Okay, so the image point is 2, the original is 8, so that reduces to 1/4. So that's the horizontal stretch by 1/4. Now we do the same thing for the y's. The original is 4 tall. The new one is 1, 2, 3, 4, 5, 6, 7, 8 tall. Okay, so the new one is 8 tall. The old one was only 4 tall, so that works out to 2. So this is a vertical stretch by 2. Okay, and we can always figure these out by taking the image height dividing by the original height. Okay, or the image width divided by the image or the original width. Okay, all good. So there we have it. Now there's been no reflections here. That's still straight up. Okay, so that's fine. Now we look. So the most prominent point is this one. Okay, the vertex for these things. Okay, so the vertex went over 1, 2, 3, 4, 5, 6. So 7 left. Okay, and then 2 up. Okay, now we just make the equation. So then y equals, okay, so we have the vertical stretch comes first, the a value. So that is 2. Okay, then f bracket. So then we need the b value. So that's 1/4. Okay, bracket again because we have to separate we have to see the b. The b has to be separate from the 7. So that's going to be x. Now 7 left is plus 7. Okay, great. And then 2 up looks like that. So this is our new function. And we go step by step, and it's really not that bad. Okay, so I want you guys to practice this stuff. Okay, the questions for this are on page 38. Start with those. Okay, again, textbook or the questions from the workspace card. Either or, but get them done. We are close to the end of this section. Thanks, guys. See you next lesson.